welcome back to Unit 7 Arrays, and in this video we need to cover a small topic before we jump up to the relations between the arrays or pointers, and that topic is arithmetics of pointers. And yes, we do can have some arithmetic operation, we do can perform some arithmetic operations with the pointers, but the things are more than just maths here, okay? And the only arithmetic operations that are allowed to a pointer are increment decrement operators, and you can only use these four things within pointers. You cannot use any sort of multiplication, division, or even subtraction. No multiplication, addition, or division is possible between two pointers. Between two pointers we cannot, but we can have an increment or decrement, or you can say addition or subtraction in the same value of pointer by an integer. Okay, only increment decrement of an integer is possible with the pointers. Okay, we can operate on pointers with integers and with these four operations only. We cannot have multiplication or division or subtraction or addition between two pointers. And if ptr is an integer pointer, and let's ignore this point and let's directly jump to the program, and you will understand that what that last point was about. Okay, so I am going to declare an character pointer and star ptr and a variable also all that is obvious of character type. I'm not bothered of or accessing, or you can say initializing the value of character, because we are going to study the arithmetics of pointer, and I'm going to point that ptr pointer to this character c. And what I'm going to do, I'm going to print out the address %p. If you remember, %p is the format specifier for the address, and ptr, and okay, let's run the program. And now you can see in here we have the address location of the variable c. Okay, now what I'm going to do, I'm going to increment the value of ptr. Okay, plus ptr, and I'm again going to then print the address. Okay, control c, command v. Okay, and let's see what we have then. And you can see in hexadecimal, this is an hexadecimal representation. It has 16 you can say 16 values or 16 different types of digits, just like we have normal numbers, or you can say decimal numbers, and the base of those numerical numbers are 10 that we use: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the old 9 digits that we can use in formation of the numbers. Okay, while we are talking about hexadecimal number, we have base of 16, and we can use 0 to 9 and then a to f. Okay, and the cycles goes on. After f we again comes to 0. Okay, so when we are talking about, so that is why we have 0 in here. 7f, and the increment of +1 in hexadecimal will yield 80. And you can see if I increment this one more time, we should see 81. Yes, you can see 81. So this is how the addition operation, or you can say a subtraction operation, works. And if I'm going to decrement it once again, then I will again come back to the 80, command v, and minus. Let's see what we have now. You can see I incremented that, and I again decremented that. That is why I was shifted back, or you can say the pointer was shifted back to the memory location just behind the memory location that it was pointing to. So pointer is getting shifted by a unit of memory, That is why what is happening over here. So what if I have an integer pointer pointing to an integer variable? Okay, so I am just changing the type of the variable and the pointer. So let's see what we have in here. So the pointer was stored in 37C, and then we have 380, and then we have 384 and 380 again. There you can notice that there is a jump of 4 units, or you can say 4 memory blocks. The pointer jumped by 4 memory blocks, though the increment was of a single unit. One increment was of 1. So this is what makes difference in the arithmetics of pointer. If pointer is an integer pointer, then plus plus ptr will be incremented by 4 bytes. In the case of floating point variable, it will be incremented of 8 byte. And you can see in here, or you can, I guess you can now guess what is going on here. The size of the pointer matters here. If we are going to increase the pointer by some units or some integer number, then it will get incremented, or you can say shifted by particular number of bytes that pointer is storing. In this case, pointer is of 4 bytes. Okay, or you can say it is pointing towards the memory block of 4 bytes. So whenever the pointer will be shifted, it is only going to shift by 4 bytes. It is not going to shift by 3 bytes, 2 bytes, or 1 byte. Okay, and you can see here, if I increment it by, now after subtraction, if I increment it by 2 values, okay, or you can say increment by 2, ptr or is equals plus equals to 2. I am incrementing it by 2 integer number. Okay, or you can say 2 integer units. And you can see here we got 88. Why we have 88? 4 times 2, that is 8, and 80 times 80 plus 8 is 88. That is why we have 88 as a result in here. Okay, the thing is, the size of the pointer, you can say the size of the data type of the pointer matters here. If you are going to increment it by 3, then it is going to shift by 3 times 4 bytes, because pointer stores byte it, and we are incrementing it by integer, and that integer is specifying that you need to shift this amount of time, or this number of time, and by how much is the size of the pointer. And this is all about the arithmetic of pointers, and you can even use this syntax in here, and the answers will be same. You can see here, and you can even decrement value by in this manner also. And you can see here we got 78. Okay, and no need to confuse yourself, these are not just numbers, they are hexadecimal numbers. If you are going to decrease it by 4 units, then this is the answer you are going to receive. Okay, and this was all about arithmetics of pointers, and in next lecture we are going to talk about how pointers are related to arrays.